So next up, you guys all know who this is Yehuda Katz of Engine Yard and Rails Core fame and MERP fame. There's no more I can say. So that's it. I'm going to leave it up to Yehuda. Take it away.
Okay. Can you guys hear me? All right, sweet. Power. Okay. Just getting comfortable here. Okay. So my talk today is called Interfaces and the Future of Ruby, which is, I guess, a highfalutin topic. I'm here to talk about Rails 3, but I'm going to focus on how we're making better interfaces in Rails 3 and how that might affect Ruby beyond Rails. So that's the reason for my topic. Could easily have been called, what's new in Rails 3, or here, learn about Rails 3. I'm focusing heavily on sort of the extension API, the part of the API that you would dig into if you were doing beyond just the top-level view of Rails. There's, of course, a lot of stuff that we're working on the top-level view. You'll hear more about that in the couple of months to come. But I'm focusing today on the internals and how you could leverage the fact that we've improved the situation there to build better apps. So first of all, who am I? I'll skip this Yehuda Katz slide. Whoa, all of my images appear to have vanished. Okay, I'll just skip all that, and I'll tell you what I would have said if I had images. I'm Yehuda. I work for a company called Engine Yard. Engine Yard is really great. They basically fund all the work I do. They've funded all the work I've done for about 2 years now. That includes a year of work on MERB and 9 or so months on Rails. They also fund Carl Lurch, who used to work on MERB in his spare time, got hired to work on EY Cloud, and eventually moved on to work on Rails. So me and him pair every single day. And if anybody's skeptical about pairing, Carl and I do work that we would not be able to do without pairing. And so a lot of people think that pairing is mostly a training thing, and I think that's definitely one possible use case for it. It's also very useful if you have really hard problems. So maybe there's like some medium-sized problem where it might not be appropriate, I guess. But training and really hard problems are a really good use case for pairing. I have one little pairing anecdote before I move on to the Rails stuff, which is I was sitting on a plane a couple of weeks ago, and I do that a lot these days. And I was sitting next to a pilot, and he asked me what he did, and he had like made some PHP site for his for his daughter, so we had something in common, I guess. And he was asking me, what do you do? So I telling him about Rails a little bit, and I was talking about pairing, and he said to me, I didn't need to say anything else. He said, that makes perfect sense to me. I couldn't do the job I did if I wasn't pairing. He has a co-pilot, and he said, it doesn't really matter to me if I need the co-pilot there at any particular point in time. Most of the time it's just there as a backup. But when you really need the co-pilot, you really need the co-pilot. And I feel the same way about pairing. A lot of times I could probably do the work I do myself. But when I get into a dangerous area or start working on something really hard, I'm glad someone's sitting next to me that can actually do the work. So just if people are skeptical about it, I know at one point in my life I was skeptical about pairing because I'm a pretty good programmer and can pull it off usually pretty well. And we're more than twice as productive with 2 people than the 2 people would suggest. So anyway, so who are you? Since you're here, I assume you're all Rubyists. The most obvious Rubyist is application developer. Application developer is the left side. When you start working on Rails, you're just an application developer. And over time, you move on, you become a power user. Definitely missing some images again here, which is fantastic. So, it's pointing at actual things. Something obviously got messed up, but I can improvise. So when you start off as an application developer, you move on life till you become a power user. And that, a lot of people think, that's sort of, some apps are application-y, some apps are power user-y, and there's definitely an aspect of it that's that. There's also an aspect of it that's as you grow as a developer, you go from being a simple application developer, you go to API at rubyonrails.org, that's your life, you never look at the Rails source code, you use plugins, don't really look into how they work. That's sort of the beginner style. And then as you move on, you spend more and more time inside the Rails source. You definitely look at the plugins that you use before you use them, make sure that they work correctly, aren't going to interfere with what you're doing, really understand how Rails works internally, know how to sort of bust in and make some changes if you have to. And There are applications that work that way. There are people that work that way. But over the lifetime of both an application and a person working on Rails, it becomes more and more likely that you move over into power user territory. I'll just skip these non-images. Historically, Rails has been very good at the application developer. MERB was created mostly to take care of the power user end. So, Rails is great if you're starting off, but once you start having to dig in, people felt a lot of pain. So we moved off and basically made a framework for that hacker group. But the point of Rails 3 is to integrate that so that as you move up from application developer to power user, you get that smooth slope of goodness, just the same way that the API was great when you started working on Rails. As you start needing to do different things, swapping out functionality, adding hooks, anything like that, it's the same pleasant gradient as it was when you started. So that's sort of the point of Rails 3. I'm going to take a little detour here into programming. So what is programming? The very simplest type of programming is procedural programming. So back when programming got started, programming was basically just a way of handling control flow. So this is even more complex than the early programming, but it's sort of, you can have an if statement, you can have loops. In assembler, this is handled by like jumping and compare if equal and whatever. But you basically have a big glob. This is a very, very small thing, but you basically have a huge amount of this all wired in together. And that's how procedural programming works. You can get some good syntax for procedural programming, but in the end, it's just a big ball of code with no obvious entry and exit points, just a big ball of code. And that works fine until you start to notice that, hey, a lot of this code looks the same, or I'm reusing code. And in the assembler procedural style, you use goto. You jump back to where you have to go, and you get cute about calling conventions. I'm going to put something on the stack here, and then when I go here, it's going to know to pull it off the stack. And you end up basically inventing all this ceremony to handle handle repeatable code. So the solution is basically to have some kind of subroutine. Subroutine takes that procedural code and wraps it up into a box. And you start with, you have an entry point, then some stuff happens in there, and then you get some output out, right? And the real benefit of this is that you have a black box. You don't really have to know what goes on in there, although you might want to. You have a black box that you can wire up with other black boxes, right? So now you can create programs that are of higher complexity, because when you're developing at that higher level, you don't have to worry about what's going on inside each of the black boxes. So what do you get out of this? Number one, you get a better interface. So you can get something like ruby.h, which is just a list of interfaces. You have rb_str_new, takes in a car star and a long, and spits out an object. rb2id takes an object, spits out a symbol. rb global variable get takes a car star, spits out an object, right? So you can now say clearly to your users, not you have to go to line whatever or this label, and you have to handle these conventions, right? You have a clear, here's a bunch of interfaces that you can use if you want to interact with me. You can build a contract on that, right? Ruby.h is a contract. Rubinius is able to take Ruby.h and have the same contract apply to its internals, even though it's completely different inside. Those little boxes work differently inside, right? And finally, conventional. You don't have to worry about the fact that I'm going to write a function, and I'm going to have to worry about what the calling convention is to call the function and how I get the return value back, or how I show that there's arguments, right? When I'm writing code, how do I specify an argument? And basically, you get a standard way of doing this, because now the language has functions. There's a standard way of putting things on the stack and getting it back and all this, right? So it basically means that this sort of thing is effectively identical to this, and so programmers can treat it like just a box. Like I said a minute ago, it also means that it's changeable. You can take mysql.h and replace it with your.sql.h, and that works just fine. And there are people out there who have made MySQL workalikes. Basically, all they have to do is take the contract that mysql.h provides, do the same thing, different internals, everything works. OK, so we have effectively something good with procedural programming. But eventually, you start to do a lot of this. You notice that there are state that gets passed around. That's the little green dot. I'm not sure if you can see it back there, but you end up chaining a bunch of this stuff together, and you end up seeing that there are state that gets passed around, maybe even functions that start with the same name, right? And if you see that a lot, and you even see that in Ruby code, where obviously, which is where I'm getting to, you start to see patterns where a lot of the same thing is getting passed around a lot. right? The solution is to go up another level of abstraction, to create an object that encapsulates that state and has a small number of inputs and outputs, which are similarly to the way that each function had an input and output. Now you have a class which has inputs and outputs. And we get basically the same wins out of this. Now we have a contract for the entire class. We have conventions. You know how to instantiate. You know how to pass things in. There's some instance variables usually. You know how to specify methods. In non-insane languages, self does not have to be provided all the time. And it's very easy to change out one implementation of a class for another implementation of a class. Basically, what this means is that you can take a class that is supposed to handle one thing and replace it with a class that handles another thing. Now, some languages are better or worse than others. In Java, you have to do a lot of stuff up front to make sure that this changeability is possible, right? You need some dependency injection thing to make sure it's possible. But bottom line is that if you do the right thing, you have a contract that you can easily replace out with another identical piece of functionality as long as it obeys the method names and what they're expected to return and all that. There's actually yet another level of abstraction here, which is you start to notice that you're actually writing the same function methods over and over, but they work on different classes. They work on different selves. So you have a piece of functionality, which is procedural. It has the notion of a self, maybe uses some instance variables, but it's not obviously belonging to any specific class. It belongs to any bunch of classes that happens to do something, the same kind of thing. And that is basically a module or a trait. Right, so Scala calls it traits, Ruby calls it module. It's not exactly the same thing, but functionally what this allows you to do is create a bunch of methods somewhere which are adjectives. Right, you can think of classes as nouns, I am a person, and you can think of modules or traits as adjectives. In Ruby we have enumerable, comparable, right? These are adjectives. These are effectively the same thing, a bucket of methods with self and possibly instance variables, but they get attached onto classes. And effectively, at runtime, the module evaporates and you have the same thing, right? And you get the same win here. You get a contract. Enumerable behaves a certain way. As long as you provide each, you get these other methods for free. It's a convention. Here is how you include a bunch of methods in Ruby. You make a module, you call it a module name, you add a bunch of methods. You can know that self behaves a certain way. It's going to be, super is going to be evaluated at runtime to point to the next module, right? Get a bunch of conventions, and it can also be changed out. So if I have a class action controller base and I pull in the rendering module, I'll get to all this in a minute, it's very easy for you to replace out that set of functionality because it also uses a certain contract. It uses a certain set of methods that take input and output and behave a certain way. And as long as you obey the same contract, you can it's not only that you can replace out the entire class, I want a different controller, you can replace out specific parts. So what does this mean for Rails 3? Now that I discussed that a little bit. Rails 2.3 looks like this. There are definite components. We have active record, action controller, action view. They're in different directories. But when you really start to look at it, action controller assumes a lot of things about action view. It's not easy to take action view, replace it with something else, because you have to implement a lot of interconnectedness. And that interconnectedness is not documented, right? So, and nor is it considered supported. So if you decide that you want to monkey patch something, you're basically always working against internals. And that's how it works to extend things in Rails 2.3, Rails 0 to 2.3, right? In that it looks like there's some components, but everything's kind of coupled without any obvious separation. Rails 3.0 works differently. So we still have something which is action controller, but instead of a thing called action view that action controller cares about, we have an API, which is action view compliant. And action controller cares about that, and if you replace it with something else that works the same way, everything's fine. Similarly, instead of dealing with active record, we figured out what action controller cares about in terms of active record, documented it, and now you can use any active model compliant library together with Rails. So what do I mean by this exactly? For action view compliant, you might think that there's probably a lot of things, because action controller and action view in Rails 2.3, if you've ever looked at the internals, is very complicated. There's a lot of things going on. There's a million paths from action controller to action view. But we actually got it down to a few things. And actually, this is even a little out of date. It's even simpler than this. First of all, you have to implement your action view .for controller, and this is out of date. It used to take paths and assigns. Now it just takes controller. So for controller takes a controller. It's required to return an instance of the action view object. And that action view object is required to have 3 methods on it. Render template, which takes a bunch of options. Options is an options hash, so I'm kind of hiding the fact that there's a bunch of things it has to do. But you can decide which features you want to implement. So there's a bunch of options that you would support if you were a complete implementation. But because it's an options hash, it's very easy for you to support. I only care about partials. I don't care about collections of objects. That would be very easy to implement and do integration in cases where you didn't want to support the whole API. Render partial, similarly, it expects to get back a string, both of these cases. And that's actually it. So as long as you have an object that takes for controller, returns a view object that has render template and render partial that takes an options hash, that's it. Action controller is happy. There are some specifics of what the options hash is, but that's basically just the API. That's the method call of what for template, render template, and render partial do. Active model template, again, you might think that there's a whole bunch of stuff. It seems like active record is pretty tightly bound to action controller. There might be a lot of things you have to implement in order to make it work correctly. Turns out that when we really dug in and documented exactly what parts of active record were being used, there were only a few of them. There's new record question mark, which is just basically whether or not this thing was persisted. A lot of people lobbied to use a different name other than new record question mark. And I think I pedantically agree with them that there's some better terms for persistence, maybe like persisted question mark. But the fact is that the best way to do this was to say, instead of going through all of our integration code and changing all the method names, we're just going to say that the API is whatever active records API is right now. And I'll get into it. There's only a few more methods. And then we'll just, I'll show you soon, we'll make it so that anything can implement that. So new record question mark is effectively saying not persisted. Valid question mark is assuming that you have the ability for a record to be invalid and have errors on it. You can respond to valid question mark with false to say this is not valid, should not be saved. Errors is an object that is effectively a hash. So it's an object that you can pass in a key, hash key representing the name of the attribute, and it will tell you a string, which is like here's the actual error. And then it also has a full messages method on the errors object that returns an array of all the errors, so that it can be printed out in error messages for. And finally, there's a object called model name, which sits on the actual class. And model name handles the fact that when you redirect to something, it has to go to the model and figure out what the right path for that is. Or if you say render partial some object, that some object is converted into a partial name. How does it do that? Well, there's a method on the model name object that does the right thing. You can either use the model name module that comes with Rails now, and that will do the right sorts of manipulations that you would expect on a Ruby object. So it'll convert it to underscores, and then it will convert : to slash, right? The sorts of things you would expect out of a Rails object. Or if you have a more complex model and you want to simplify, for instance, right now JRuby's Java objects are like Java : Java lang : crazy. You probably don't want to actually have it convert. You don't want to have to put your templates in Java / Java lang / whatever else. So you could implement this model name object however you want, and that'll specify how your path should be converted and all that. There's, I think, 5 methods on it: singular, plural, partial name, I think. So there's a few methods that basically you can either take the defaults, which is what you want to do in most cases, like data mapper would just take the defaults because it's just a regular Ruby object, or if you're dealing with something weird, you can implement it yourself. Active model. So what I just said is active model compliant. There are basically 2 pieces to active model. I talked a little bit about the API. Active model also comes with a bunch of pre-baked components. So what happened a lot in Rails 2.3 is that you say, I want to build a CouchDB adapter. I want to build a MongoDB adapter. I want to build a Bigtable adapter, right? And basically, you just want validations to work exactly the same. You want naming to work exactly the same. You want everything except for the persistence part of it to work exactly the same. So a lot of people like copied and pasted code or ripped things out or tried to include modules. There's a few CouchDB adapters that try to be like Active Record. But the bottom line is that there's no reason why we couldn't extract that out, put it in a separate library, use that library in Active Record, and then you could just use that same library yourself. So the most obvious candidate to start with is validations, and I'll show you how validations work in Rails 3. So here we have just a regular class, person class, and the first thing we're going to want to do is include active model validations. So we just include our validations module. And now, because we included the validations module, we have access to validates presence of, which is exactly the same validation that exists in active record. And you'll notice that we're not doing anything special with our initializer. We're just making an attr accessor, which is how active model thinks about attribute access, and then defining an initializer to say, take the name, set the name. If we make a new person, we of course do it using regular Ruby mechanisms, and we can say, is the person valid? And in this case, the person is not valid. The person isn't valid because the default initializer takes a nil name, and we said validates presence of name. If we ask it for the errors, it'll return name cannot be blank. This is actually just a default English one. Their active model comes with locales, so you can either use the default, the locale versions that are out there, or you can make your own for your own language. But the error, you basically get localed errors for all the default validations for free as part of active model. And now if we make a new person, let's say person.newMats, and we ask if the person is valid, we get back true. So that's active model validations. The second part of it is the API, like I talked about. So if you want to take a regular plain old Ruby object like this person and have it work fine in Rails, you have to implement the API. And let's look at what does that look like exactly. My benchmark for a lot of this stuff is can it fit on a slide, by the way. So here we have our person object again. And like I said, we have to implement new record. In this case, I have a persist method, which just does @persisted equals true. Doesn't really matter how you handle this. In this case, I just said that new record is persisted. In real life, you'd want to actually persist things. Finally, toModel. I didn't talk about that very much, but so we could just say you have to be compliant. You have to make your object be exactly the same as the active model API. It's actually pretty small. We could have said that. But what we realized was that people out there might already have objects that have an errors method on it, right? Or a valid question mark method that doesn't exactly conform to what Rails' expectations are. And so what we've done is we've created a new method called toModel that sits on your object. It could return self if you're happy, if you're compliant, if you do the right thing, or it could return another proxy object that implements the right stuff. So we call toModel on whatever object you pass into form for or redirect to or all that to convert you into the canonical Rails-friendly form. In most cases, that's going to be self. In a few cases, SQL is the case that comes to mind, SEQUEL library. They already have an errors object that's not compliant. So they're forced to make a proxy object that implements errors the way we expect. In the vast majority of cases, you're just going to implement. Everything cool there? Yeah. Sweet. In the vast majority of cases, you're just going to make your model compliant. And that's just going to work. OK. I talked a little bit about naming before. You need to do this as well. You need to pull in active model naming. And that gives you, that means that it knows how to get the singular, plural, partial form of all this stuff. Also recommended but not required is that if you create an initialize method, you take attributes. Rails doesn't care about this at all, but when you go and make your controller, you probably want it to look kind of like regular controllers and do kind of the regular nice things that Rails does in controllers. So taking a hash of attributes for your initialize is probably the right way to do it. Again, this is just a recommendation. It's not required by active model, but it's probably the way you want to do it. OK, so now let's look at the controller. So we have a regular people controller, inherits from action controller base. Nothing special here. And in our new method, we just say person equals person.new params person. And this is why I recommend putting in a hash so that it looks kind of exactly the same as everybody else, right? So you've now made a new person with params person. Create is a little bit more complicated. I did person.persist there, which is the method I added. But the interesting thing here is that you can redirect to person path at person, and that just works. That does the right thing. All the crazy Rails magic just works. OK, what about views? So error messages for person obviously is going to work just fine because we implemented all those error stuff. You can do form for person. Remember, this doesn't inherit from anything. All it does is be a regular Ruby object that includes validations and extends naming. And you can also do f.text field, which will pull a thing out of the right attribute. OK. So Ruby Awesome. So Ruby is 1.5 megabytes of RAM when you boot it up, and you might expect that all the stuff I just showed you probably pulls in like the whole active support and like the entire Ruby standard library, and obviously all of Rack and all this stuff. So probably you might think, oh, I'll probably use this in Rails, but I would never use this outside of Rails. That doesn't make any sense at all. It probably pulls in all kinds of stuff. In reality, everything I just showed you, getting all the validation stuff working, that just adds an extra 1.5 megabytes. So that partially that's because we use a small amount of features, but that's actually a pretty big deal. It means that you could use a small amount of features and not worry about pulling in all kinds of stuff. So if you have a project that wants to have validations that maybe isn't a Rails project, and you just want the Rails validations to work, you can do that, and they're basically no memory. Action Pack. So Rails 2.2, I think, added this concept of metal, and the idea was Rails has all this overhead. There's a whole bunch of Rails overhead. What if you just want something bare on the metal on Rack? I don't want to have to worry about rendering all this extra stuff that happens in the controller. And so there was this thing called metal, which is basically a glorified Rack handler. And if you then wanted to take that and move up to a full controller, you moved up to a full controller, and you got all that extra overhead back. Rails 3.0 says, why can't we just build the actual real controller on top of what we call metal, right? So let's make metal the base of the entire controller system, and we'll add in the features that we want to build the full action controller base, which means that you can then add in the features that you want on top of metal. So let's say you realize you need rendering on top of your bare metal, you just have to pull in rendering, right? So that's how metal works. I have some repeated slides from earlier this week when I was in Brazil, so the constant names are from then. So step one, you inherit from action controller metal. In real life, you would probably never do this. You would use action controller base, but if you needed performance and you were going to use bare Rack handlers, this is actually pretty good. This is pretty performant. So you inherit from action controller metal, and the API just set the response body directly. Self.response body equals hello world. Now, you could use the router, but if you don't want to, if you just want to get how Rails works without the router, you can set up a new Rack builder, and you can map any path onto the controller name .action, the action name, and that gives you back a Rack object that you can run just like any other Rack object. So again, you probably would use the router in real life. The router in Rails 3 is going to be very fast, but this goes to show that there's no magic in the router. There's nothing special in the router that makes Rails work. You can just get a hold of a Rack object that's the action and give it in. It'll work with all the features that you need. Okay, so one of those features is callback. So I just made a very simple thing that does self.response body equals whatever. What if I want callbacks? That's a very common request. Very similar to what we did before with action active model. You just pull in abstract controller callbacks. Abstract controller is a controller that doesn't know anything about HTTP. So action mailers can be built on top of the same API. You'll be able to use the same callbacks layout rendering code in action mailer as you use in action controller. So we include the callback system, and now we get before filter, which is what we expect when we get callbacks. And we can define set name. We can call private. It basically works exactly the same. So we've just added in callbacks, I forgot to say the first slide actually renders in 8 microseconds, which is basically no time at all. This adds a little bit of time, maybe a few microseconds, but not a ton of time at all to render callbacks. And we now have a callback API that's basically identical to the Rails callback API without having to suddenly jump up to the full action controller base. Another common request is rendering. So I want to actually render a template. So the first thing we're going to do is we're going to include the rendering module. And as I continue to work through this, you should notice that that's really the pattern in Rails 3. You could use the full active record. You could use the full action controller. That'll work fine. That includes all the modules. Or you could use a stripped down version, a simpler version, your own object, and you could pull in just the modules that you need. So because we're not running a full Rails, Rails doesn't know where to look for the view path. So we'll tell it that the view path is rails.root/app/views. And you can obviously set that to be anything you want, and that works in regular Rails controllers as well. And then the normal render works fine. Render template index works great. And in show, we can set an instance variable and say render template show. And just like in Rails, where instance variables are going to be available, it works just fine. And again, because my metric is how can I fit it on a slide, and I didn't want to add a router, I just added another line that points the show action to the show action. So actually, this slide runs. There's requires missing on the top, so you need to require a few things, obviously. But this code runs by itself as a Rails app, Rack app, whatever you want. Layouts. So I want to go beyond rendering. I want to add rendering layouts. Layouts actually are expensive even if not used, simply because you have to check to see if you mean to use it every time. It's, for a variety of reasons, it's very difficult to cache. I never want a layout, ever. So we allow you to opt out of that. You know, you could just use rendering without layouts, but you might want layouts. You pull it in, and that gives you the standard. That gives you the standard layout default. I don't know what's going on here. Okay, that gives you the standard. I'll just walk through it. That gives you the standard layout default, and you can now, it adds the layout option to the render method. Oh, I see. Sweet. Another no picture. That was a picture of dog food at some point. Okay, so the big thing here is that you could think that we're just going to expose a bunch of APIs, hooks that you could use that work fine. You know, you could include callbacks. You know, hooray, it's going to be pretty. But you know, who knows if that'll work, right? Maybe it'll suddenly break in some future version of Rails. And the reason we know that that's not true is that the entire Rails 3 is actually built on top of the same stuff. So Rails 3's action controller base is just class base inherits from action controller metal, include a whole bunch of crap. And so we include all the modules into action controller base, so you can be sure that those same modules will work exactly as expected if you decide to write a stripped down version. We actually go as far as to make sure that pretty much everything we want to do in Rails uses hooks and APIs, make sure that the hooks are really fleshed out. So one example is Rails 2 compatibility. Instead of putting all the deprecation warnings directly inside the code, we want you to be able to say, I know I'm good. I don't actually have any deprecated code. I just want to eliminate the overhead of having to deal with those special code paths. Because deprecated code still has to say, like, if the thing I used to do still works, then do it. Otherwise, do the new behavior. So we want you to be able to say, like, I'm good. I don't need the deprecated behavior. I don't want to pay for it. We also want to have a single place where that code is. So we know that, like, after Rails 3.0 comes out, we could delete that file in Rails 3.1. It'll still work. So we have a module called Rails 2 compatibility. It has a bunch of stuff in it. Here's one example. So in Rails, you might think that figuring out what the action is for a given method to call for a given action is pretty easy, right? If it's indexed, it's indexed, done, right? But actually, there's a lot of special cases. First of all, there's hidden actions. If you hide the index action using hide action, you don't call it. If it's private, you don't call it. If there's no action, but there is a template with the same name, it's valid, right? So there's whether or not something's an action is actually kind of complicated. So what we did was we made a method called method for action that by default just says it's the name of the method, and then gets extended as you go down the chain to add support for things like, you know, if you're in, if you have a template with the same name as the action, that should work. And I'll show you kind of how that's handled. So here we have a different case, which is in Rails 2.3, method missing was the catch-all action. The problem is that method missing is actually used for other things and produced all kinds of weird effects, like especially when you had a bug in which you called the wrong method, all of a sudden your catch-all action was getting called, and very weird behavior resulted possibly at runtime. So not very good. So what we wanted to do is instead say, we'll just make a new method called action missing. That is the way that you handle, that's the catch-all action. And you can go back to using method missing for what method missing does in Ruby, which is the method wasn't found. But we still need to support method missing in 3.0 because we support it in 2.3 and we're trying to be pretty good about backwards compatibility. So the first thing we do is we call super, which just says all the other code out there that handles method for action, try to do it. If there's no method for action, and in this case it's because you have a method missing, but there is no actual action called that in any of the parents. There's no template called method missing. There's no, the action name is not method missing. So the normal Rails 2 or the Rails 3 code paths don't know how to handle it. If there's no return value, check to see if you respond to method missing. If you respond to method missing, call, return the method handle method missing. So basically what this says is, if there's no actual method, but method missing is found on the object, then the action is handle method missing. And the handle method missing method simply just calls method missing action name.toSim, right? So effectively what we've done here is we've removed the need to say in Rails, we don't have to ever say, if you're in, if you have method missing, then raise deprecation warning, or like, active support deprecation.new, et cetera, stuff. And then all that has to be checked every single time, even though you're not using deprecated code. Now we can see, like, here's the actual stuff we're deprecating. Okay. Active support. In Rails 2.3, you say require active support. It pulls in the whole active support. That's the end of the story. In Rails 3.0, the equivalent is require active support /all. This is probably fine for your own application where you don't want to have to care about it. Maybe if you want to tune it, that's fine. This is never going to be okay for plugins. If I ever see this in a plugin, I'm not going to be happy. The Rails core team is pretty much on board with this. We want people to be able to write Rails applications in which they just pull in the parts of active support they need, which means that if you write a plugin that requires active support /all in Rails 3.0, everybody who uses your plugin is now forced to use the entire active support just because you were lazy and didn't figure out which parts of active support you actually need. That's actually a pretty high burden for regular app developers. We don't want regular app developers to have to know all the little pieces of active support and what they do. So for regular app developers, the default is going to be all. But when you write a plugin, there's a higher bar. You should figure out what functionality you need and require it. That way, arbitrary things like RexML, which we need to require RexML so we can apply a security vulnerability patch. If you don't actually require RexML, you should not be getting RexML pulled in because it's pretty huge. So that's one example. Time and date libraries are another example. You want people to be able to use your plugin in a very tuned environment. Something that will be included by default, no matter what, that Rails requires, so this is something Rails is going to require, is active support Ruby shim. And this is basically things that are in Ruby 1.9 that are not in 1.8.6 that we want to use right now anyway. And here's a list of them. So we have stuff like date, next year, next month, which are in 1.9. We have date time. We have stuff like enumerable, group by. This is stuff that was added to active support first and pulled back into core. Object.tap is used a lot. Then we have process.daemon, RexML security fix, like I said. RexML security fix will not be pulled in if you have Ruby 1.87 or higher, because it will already have been applied. So you probably want to be doing that. And then string.org, symbol to proc, those are all part of Rails by default, no matter what. So basically, the idea behind Ruby shim is, why can't we have from future import star, right? Ruby's a very flexible language. We should be able to implement a lot of 1.9 features that are not parser features in 1.8 if we want them. Frequently, Rails does want these features, so let's just do that. Let's just give them to you. Require active support Ruby shim, done. Another aspect of what we're doing with active support is trying to reduce the amount of pollution. So again, by default, it's very convenient to have stuff like .camelize. So we're not going to eliminate .camelize from your default app. That would probably break everybody's app, right? But what we are going to do is we're going to internally use active support : inflector .camelize, and therefore, it will be possible to not include the parts that pollute the namespace. A classic example of this is JSON. So a lot of people have had a lot of complaints about active support overriding to JSON. What I think a lot of people didn't realize, or in their complaints ignored, was the fact that the problem was actually that two people were doing it. The problem was that the JSON gem did it and active support did it. So a lot of people said, oh my God, I can't believe how bad active support is. They're breaking the JSON gem. No, active support and the JSON gem were both doing the same bad thing. It's just that Rails actually cared about the results of to.json, and the JSON gem itself didn't. But people should not be writing code that relies upon the actual value of a core library extension. So if you extend object to have some foo method on it, you should not in your code, in the code that you've written, rely on object.foo existing. You should have some modularized method like active support object.foo that you use internally, and then maybe expose the .foo for convenience to your users. And that's what we're starting to do in Rails. There's definitely a lot of places where that is not done in Rails, and I actually doubt it will be done entirely for Rails 3. which is why this slide, the previous slide said less pollution and not no pollution. But the goal is to start moving in a direction where we're not relying on core class extensions, especially ones like 2JSON, which could happily be made by somebody else. What we're also doing is we're allowing you to specify what the backend is. So we're defaulting to our really bad YAML thing that like takes JSON, regexes it into YAML, and then uses the built-in YAML parser. I don't know if you know that, but that's how JSON parsing happens in Rails by default right now. Which means you should probably have the JSON gem installed, because then it will do that. It's probably the right way. So active support JSON backend. JSON gem is one way. Then there's Yagil Rails, which is another JSON library that is a stream parser, which is not really why we use it. It's pretty fast. So basically, we're allowing people to make their own JSON backends that conform to a certain API, and then we'll just use that if you tell us to. So we default to JSON gem if we have JSON gem. Really bad YAML parser if you don't have JSON gem, and then there's some other ones available like Yagil. Bottom line is that you should think about active support like an extended standard library. Nobody wants to do that, because just like if the standard library was require standard library, I don't think anybody would have ever used it. Right? That would be crazy. You're not going to pull in every single part of the standard library just to use time.rb. Right? So the standard library allows you to require time.rb. Active support in Rails 3.0 allows you to require active support corex time.rb. So you can now start actually requiring just the pieces you want. So you can treat active support like an extended standard library, and everyone can stop rebuilding active support. Right? This is actually bad. If there's a bug in active support, please help us fix the bug. It's actually really problematic to have multiple entire core extension libraries loaded in people's processes just because you didn't think you liked active support, so you built an entire replacement. I can't really complain because I'm one of the people that built a replacement, so I think that's fine. It's not something I get to complain about, except to say that from here on out, that should stop being the way it is. Data Mapper is going to be using active support in future versions, obviously requiring just the pieces that it needs, and that's what you should do. And you should just. It's okay to have active support installed in your system, and it's okay to say require active support corex time.rb. That's an okay thing to do now. We're also being very careful about cross pollution. Like time.rb does not require arbitrary random insanity. Some interesting things before I close. Performance. I just worked for the past couple of weeks on performance, and here's basically the results. These are index action, rendering a template, rendering a partial, rendering 10 partials, rendering 10 collections, a collection of 10 partials. The little blue square is Rails 3 microseconds, and the green one is Rails 2.3 microseconds. The Rails 2.3 is the full bar, including the blue part. So we're a lot faster now, this many times faster. That's overhead, of course. It doesn't mean your app will be 5 times faster. It means that the overhead of going and calling a template is pretty cheap. Comparatively. The thing is that it actually matters. So a lot of people say like, oh, that's overhead. Once you pull in like your real app, that's not going to really matter anymore. If you look at stuff like rendering a collection of 100 partials, you start to see that like Rails 2.3 takes like 9 milliseconds to render a collection of 100 partials compared to 2 milliseconds to render 100 partials in Rails 3. 8.3 milliseconds to render a collection of 100, or 0.8. So you start to get into actual real time once you start rendering big collections. And so I know some people on the Rails core team don't like you to say like we're like 10 times faster. They're like 10 times what? Is that like 10 microseconds instead of 1? And to some degree that's what's going on here, but to another degree it makes it actually viable to use collections. One of the things that I've worked on is in Rails 2.3, rendering a collection of 100 items is basically like rendering 100 partials. But actually, you don't need to do that because there's a lot of information that's the same. Like the actual template is the same every time. You don't have to go look it up every time. You already know what the name of the variable is that you should be setting. It's the same one. It's the partial name every single time. So in Rails 2.3, all that stuff is looked up every single time. You go get the partial name again. You go reset it into the hash. This is stuff that gets cached, and now the actual loop of a collection is very small. So it's just actually rendering the template a lot of times instead of a whole bunch of other overhead. So we can actually do this stuff in Rails 3 in part because of much simplified code paths. But the bottom line is that if you're doing a lot of rendering, that overhead you may have already noticed actually starts to kill you. I know people who have actually pulled things out of partials and put them back into the regular part of their template because the overhead was just too high. Again, a lot of people dispute that. They're like, well, what are we talking about here? A few microseconds? the truth is that there is a lot of overhead in Rails 2.3 that is now eliminated. Rubygems. People don't understand this problem, so I'm going to explain it so that you can all go home and tell your friends what the problem is. We're also fixing it. But nobody understands it, so I'm just going to show you a picture of it. So here, I have an app. It has two requirements, Rails 2.3 and Active Merchant. Okay? I have in my system Active Support 2.3 and Active Support 3.0. I go and activate Active Merchant. Active Merchant says I want Active Support greater or equal to 2.3. I have Active Support 3.0, hooray, gets activated. Then I go and activate Rails 2.3. That requires Active Support 2.3, tries to require it. Big boom, you get this exception, which you probably have seen in real life more than once. Can't activate whatever, already activated something else. So the problem here is that we're doing it linearly, and the order that you do it actually matters. One workaround is just to do it in a different order. Figure out what the right order is, do it in that order. That works. The right solution is to have another thing that all the dependencies feed into that go and figure out, you actually want Active Support 2.3. Right? And then you require it, it works. This doesn't solve general conflicts. If you actually have conflicting gems, we can't solve this problem for you. But if you have multiple gems that just have sort of vague ranges, and there is a subset of those ranges that actually works, we can provide that little circle that you feed the gems into. And we've written some code that does that, and that will be in Rails 3. Second of all, bundling. Right now there's freezing code. It's pretty naive, works well for a lot of people. One of the biggest problems with it is that it requires you to actually boot up Rails to go collect the dependencies. That basically means that you may have a require line in there, and it actually expects the dependency to be there, but we're just in collecting phase, so out of luck. But there's a lot of other problems, like you have network dependencies on actually RubyForge at deploy time. Doesn't matter most of the time, but when it actually matters, because RubyForge is down, that really sucks. So the solution is to do what a lot of other languages do, which is just to actually stick the gems in your application. So just like in Java, you stick a lot of jars in there. What we don't want you to have to do is actually copy the gems manually like you have to do in Java. Like, I'm going to put the jar in here. We want you to be able to specify your dependencies, and we handle that for you. But what we want is we want you to be able to have an application that has everything in it. What do you gain from this? You gain the fact that you have no deployment dependencies. You have the actual dependencies, gems in your application. You can't accidentally have a situation where your dependency was a little loose and somebody released a new version to RubyForge since the last time you checked. Suddenly you have a newer version that gets deployed even though you just checked it on staging. Like, oh my God, what just happened here? Consistent environment, that means consistent environment between staging and production, but also consistent environment between your application on my machine and somebody else's application on their machine, right? There's a .gem file that has the right stuff in it, and native gems, because now basically what we've done is we store the .gem in your system, but when you go to deploy an application or install it on a new system, we can then expand out the .gems into their full non-freeze-dried form. So native gems work fine. You just run a task, and that task expands out the gems that are in your system that are .gems. This will not work for like if you have a JRuby app that has RMagic for Java and you're developing on MRI where you use RMagic for C. Obviously, we can't do anything about that, but that's really not a common case, right? The common case is you just have, I'm using OS X here and I'm using Linux there, and I can't bundle the .bundle file because it doesn't mean anything on Linux. I have to actually go and expand it. So this solution handles native gems just fine, and it also allows for seamless upgrades. So you have a bunch of gems that you say you want. Let's say you say, I want any version of Active Merchant. So you can just basically run a task that will check if there's a new version of Active Merchant, go download it. It'll also re-resolve all the dependencies, so it'll make sure that if there's dependencies that don't work anymore with a new version, it all works. So what I talked about a few slides ago, the resolver that allows you to give a bunch of dependencies and give you back a set, this also works during upgrades. And that's pretty much, so that feature, the having actually good gem bundling, is going to be there in Rails 3. It's already available right now under ycat/bundler on GitHub, and there's a bundler gem that you can install from RubyForge right now. I think it's called Gem Bundler, or maybe just Bundler. I'm not 100% sure, but it'll run. It's basically you create a gem file which specifies what gems you want, and then you run gem space bundle. I don't remember the README has a lot of details on this. But it works fine in regular applications that are not necessarily Rails applications. So it's a project that exists that allows you to bundle things into your application, deploy them, expand native gems, and all this stuff. Yes?
What is it about Rails that magically breaks this?
It doesn't. It works on Rails.
But
Works on
older Rails.
It will work on Rails 2.3, but it required Carl and I had to write a bunch of hacks into it because Rails 2.3 actually overrides Rubygems pretty extensively. So we had to pretend harder to be Rubygems than we had previously pretended. So it will work fine on Rails 2.3. And Carl's coming back from vacation on Monday, and we should be having like a blog post that explains how you'd want to use it. It also means that the framework, like Rails, when it's bundled into your application, which you should do for the same reasons and network dependencies and consistent environment that you do, if you bundle Rails, it's just another bundled gem, which means that it can happily enlist in the dependency resolution stuff. So now you have active support. Active support is just another bundled gem. Active merchant will know about it. It's not like a separate place. And we're adding over the next couple of weeks the ability to use like a Git repo with a directory and tell it, this Git repo with this directory you should think it's this gem. So you can specify Git repo directory. It'll download it, check it out, put it in the same place as the normal bundle inside of your application, and then it'll correctly, during like your other gems that depend on that gem that you told it to pretend to be, will do the right thing. We'll know that it's already installed. Okay. Core principles of Rails 3. Number 1 is granularity. So Rails 2.3, for instance, people used to complain like I can't use data mapper, and the Rails core team said it's Ruby. What's the problem? Just like require data mapper. That's fine. But the problem is that requiring data mapper and throwing out active record meant throwing out a lot. So pretty much everything I showed is about allowing you to selectively opt in if you have a very performance-intensive application or a weird application, opting into just the features you want without having to opt in and out of the whole Rails, basically, or entire huge chunks of it. Instead of making the default opt-out, so in Rails 2.3, you can say like config.frameworks - active record. That API will still exist, but there's no real obvious way to say I want to start from 0 and start building up. Rails 3 is built on top of an opt-in approach, so it's still, the API still works exactly the same as Rails 2.3, but it's built internally in terms of opt-in, which means that if you want to build your own slightly different version of Rails, it's very easy to opt into something or not opt into something else. So it flips around the paradigm for how Rails is built internally. Dogfooding, we don't want to provide APIs that are just like, here's an API you should probably use, and we'll try to maintain it over time. Probably the biggest problem with Action Mailer is that it got forked off of Action Controller a long time ago, and then we constantly had to throw in, here's layouts. We'll just copy and paste it. Like layouts layouts and helpers and stuff are actually copied and pasted into Action Mailer and then slightly modified because basically a fork. So getting to the point where we're actually using all the extension points that we're expecting you to use is pretty huge and prevents that sort of thing from happening in the future because we're building up the same way that extensions will build up. And finally, you may step away from this saying, oh my God, the Rails I know and love is gone because now you have to make all these decisions and opt in. We have as strong, if not as stronger, focus on conventionality. The only difference is that conventionality extends from the user experience. You can still do gem install Rails, generate a Rails app, everything works fine, exactly the same as it worked in Rails 2.3. That conventionality extends into the internal. So there is a convention for how a model should behave in order to get Rails to work. That convention doesn't care if you're active record. Most people will use active record. That will work fine. That will continue to work fine. Everything will be great. But it's not just active record is the convention. It's active record is the convention because it implements the active model API. So basically, the combination of dogfooding and getting the conventions into the internals means that you are actually able to build your own applications in a way that respects what we love about Rails, which is that it really focuses on conventionality and not lose all of it. So thank you. And I will take any questions people have. Yes, sir. Ma'am.
Have you modularized other stuff like the routes and the like migrations and stuff like that?
So I think the question was, does this also mean you can use like the router and migrations separately? I can't speak for migrations, although if it's not true in Rails 3, it'll be true in 3.1. But a lot of the parts of Rails that people would want to use separately are actually being spun off as separate projects. So the router is probably going to be, you can go to GitHub right now, there's a project called Rack Mount, which is under Josh Peak. And that's going to be basically vendored in Rails. So there's going to be a bunch of projects that, actually, like the bundler, that are designed to be used separately and happen to be used in Rails. And so to the extent that that something doesn't need to be part of Rails and in order to be used separately, we're doing that. There's a little bit of scare of what if Josh releases a new version of Rack Mount and some other thing depends on it that wants to be inside of Rails. And that's subtle because it could happen like accidentally. It could happen where like I depend on a new thing and someone's still using an old version of Rails. So I thought that I would be able to use the new version of Rack Mount, but I actually can't. So because one of the problems with an ecosystem where there's a lot of gems out there is that you could end up with things are not synced, right? We're not releasing every single gem that is used in Rails together. So you could end up with conflicts that are not thought of in advance. Part of what we're going to be doing is to the extent that something like spun out of Rails, like Rack Mount, we're going to be syncing them. Active relation is going to be synced. But there's definitely going to be issues with that, and we're going to have to work through it. I think we're going to try really, really hard to make sure that there are known versions of all these things that work with Rails, and we work with the community to not be depending on weird versions. So don't depend on a newer version of the bundler if you expect it to work on Rails 2.3, right? Just don't do it. But the answer is yes. In general, the point is to be able to use any piece of Rails that you want that makes sense to use in isolation. The dispatcher, the router, pieces of the controller, the rendering subsystem, templates, all that should be able to be used separately. I personally would consider it a bug if you can't. So if you want to use something in isolation and it's impossible, I would think that I would consider that a bug. Yes, sir.
Newbie question. So like I assume like a site like Heroku uses a specific version of Rails. And so if I migrate to Rails 3 and Heroku is still on Rails 2.3, I assume that means my app would not work properly?
So I don't know, but maybe the guys in the back of the room on EY Cloud can tell me. I think they probably allow you to use any version of Rails.
Yeah, you can install any version of any gem version you want of Rails.
Yeah, so in general, though, this is a problem, right? Rails 3.0 works differently than Rails 2.3. So it's similar to upgrading any version. I don't think there's any reputable Rails hosting provider that requires you to be on a specific version of Rails, though. It's simply a matter of getting your app in shape.
Okay, I'll figure it out.
Is that incorrect? Does anyone know of a reputable hosting provider that requires you to be on a specific version of Rails? I don't think so.
That may be the definition.
Maybe. Any other questions? Yes,
I
sir.
have a small one, potentially stupid. Are there any known incompatibilities between Rails Edge and JRuby?
No.
Okay, that was the potentially stupid question.
Are you thinking that there are?
No, but I'll find out tonight.
Right now, Rails 3, Edge, and JRuby are not in the CI. We're working on that, and it's certainly possible. I know that I run benchmarks against JRuby, so I have some stuff I tweeted recently. So at least like Rails boots and simple things happen. I just don't know.
Okay.
There may be parts of it that don't, and we're actually working on CI. So, yes.
You showed us a little number about memory usage. I'm wondering if you have any other numbers that you could share with us that you benchmarked for the memory usage in Rails 3.
Sure. So one of the problems that I had, I did those numbers a few weeks ago, and I wanted to show memory usage for the controller. The problem is that controllers are only useful in the context of servers, and once you put in Mongrel or Thin or something, it's complete. You get to 15 megabytes or something like that, which is actually better than Rails 2.3. But it stops being particularly cool for us. Like 15 megabytes doesn't sound as cool as 3. And it's not our overhead, and it's very hard for me to measure our overhead because our overhead is you have to remove Mongrel. I could try to boot up a Rails app, like spin up a Rails app without the server and see what it looks like, but I felt like that would be disingenuous. So it was just hard for me to come up with numbers that would be useful. I can tell you that if you boot up Mongrel with a simple Rails app, it's like 15 megabytes of RAM, and it should be better on like Passenger or something, which doesn't require you to have an HTTP server in your process. Other questions? Yes.
About what versions of the interpreter?
So it runs on, right now, runs fine on every version we used to support, I think, which used to be 1.2, 1.4, 1.5, 1.6, and then whatever came after that. Pretty sure we're deprecating 1.2, 1.4, 1.8.2, 1.8.4, and 1.8.5. I'm still very curious if anyone can tell me what was wrong with 1.8.3. I would love to know, but I wasn't really around at the time, so I don't know. But at the very least, you're going to require 186. We're thinking about whether or not we should specifically say we don't want to support 187. Part of that is just that there are things we use that are backported from 1.9 and 187 that are just very slow in 186. And the other thing is whether we want to handle bugs that are basically 186 bugs. So there are some, like the RexML security fix, we kind of want to delete it. It's fixed in 187. We want to just tell people, like, you actually need 187. It would be somewhat controversial to do that, though. So we're not sure. And we certainly, the numbers that I showed you there were 1.9 numbers, the performance numbers. 1.8 doesn't do as well. 1.8 is like twice as fast for those numbers instead of like 4 or 5 times. And a lot of that has to do with garbage collection. Like the techniques I'm using generate more garbage for caching. And hashes and instance variables, which are basically cache primitives, don't work as well in 186. So we probably will recommend to people that they should use 1.9 just because it's much like it handles optimization better. So JRuby has similar properties. Like JRuby and 1.9 have good optimizability properties where, like, if I actually cache something into a hash, it's actually faster. In 186, it's sometimes not, and depending on like how expensive the underlying operation was. So at least I will personally recommend that people use 1.9 if possible. And I posted a while back on my blog, like, why are people not on 1.9, and got a lot of good answers. I think we as a community should push harder simply because of performance. Performance characteristics are so much better that we're actually hurting ourselves. I mean, it's literally like a couple times faster. And so Rails 2 is like twice as fast. Rails 3 is going to be like a few times faster on 1.9. And going out there and having to deal with people saying like, oh my God, Rails is so slow because they're running on 1.8 is kind of bad. So I would like to be able to compare Rails against like Groovy on Grails or whatever on fast versions. And so I would like people to use 1.9. And for your own good, you should probably be using it because it's fast and has better memory characteristics. Yes?
So you say, kind of knew this too. So I can run 2.3 on 1.9 right now. Is that what you're saying?
You can run 2.3 on 1.9 right now. There are a few known issues with the underlying drivers. So I think the MySQL driver is fixed now, and the Postgres driver, but there were some encoding problems in it. And I think Memcache may have had similar problems that are fixed. Ruby debug for a while didn't work on 1.9. I think something was released recently. So there's the story for actually getting on 1.9 until like a month ago was really murky. I think a lot of that is better now. I think my post actually spurred people on to like figure out whether or not what was broken was actually broken, and a lot of it wasn't, and getting the story straight happened. So if you find that 1.9 is difficult, it's probably the right thing to do is be very public about it. Like, I tried to use 1.9 and encodings didn't work. That's like the most common problem is you ASCII plus UTF-8 explode. So if there's still something returning ASCII where if Rails is still getting ASCII from some driver that's expecting UTF-8, that shouldn't happen anymore. Like we've said unknown encoding equals UTF-8 inside of Rails now, and most of the drivers return something useful, but it could happen. And so the best thing for 1.9 is not, I think a lot of people in the past have tried to use 1.9, didn't work, and instead of like yelling about it, they just said, I'm giving up and going back to 1.86. I think that's valid, was valid. Now the right thing to do is to write an angry blog post about what didn't work so that the person who's maintaining the thing that doesn't work can get it working. There's also isIt19.com, which tells you whether a gem is known to work on 1.9 or not. So I don't know. The odd thing is that 2 months ago I was very skeptical about 1.9, and a combination of performance and things seeming to come together makes me really optimistic about 1.9. And what I don't like is having to deal with objections to Ruby that are based on like 10-year-old technology, right? We actually have better technology. Like, people say like, you can't compile Ruby, right? But Yarv actually is bytecode compiled Ruby. People say a lot of things about Ruby that's not true about 1.9 or JRuby. So I would like to put the 10-year-old technology behind us so I could stop having to deal with people arguing about the actual way that the old technology worked.
Is there a projected timeline for the stable release of Rails 3, and is there a full documentation? What is the state of the document?
I'm glad that wasn't the first question. But I'll try to answer it. So the question is there a good timeline for when Rails 3 is going to be released? Answer is no, but I'll try to give you a good, as good of an answer as I can. We're actually making very good progress. I think there's a few small agenda items left before we can cut a release. I think to some degree we want to have a release that has stable APIs because we're kind of telling people that that's going to work. So we don't want to have a release where some of the APIs are rough edges and we have to do it again in 3.1. That would be bad. So we're getting to the point where we can really start making that our highest priority focus. Right now, our highest priority focus is finishing 3.0. Soon, our highest priority focus is going to be locking down what the 3.0 API actually looks like. Most of the Google Summer of Code projects that have been worked on are merged in. So specifically the generators, which were a big project, are merged in. We'll know pretty soon whether the active record work will be able to be merged in. That's a pretty big deal. So yes or no will happen soon. Action Mailer still needs to be rebuilt on top of Action Controller, the new abstract controller stuff. But the bottom line is that we're actually getting pretty close to the point where we're just working on getting plugins working. And there will be a beta period where plugins are going to be encouraged to get themselves onto Rails 3. And once we feel like enough plugins are working on Rails 3, we'll have an RC. So I don't want to give a timeline because there are contingent facts. There are contingent things that have to happen in order for us to feel comfortable with it. But I can tell you that the things that are in our control, which are Rails 3 having a pretty stable API and being basically done, is close. And the things that are not in our control, like plugins actually working on 3.0, are things you can help with. So if it's not like you writing code, it's just like harassing the people who have the plugins. We want to make sure like the top 30 popular plugins work on Rails 3 before we pull the trigger for the RC. So either help yourself or harass people. But that's the timeline. We're talking like months, not years. So, other questions? Okay, I think there aren't any, and so that means I'm done. Thank you very much, everybody.